Let's design a very simple circuit using a diode. Let's presume that I have an electrical system as shown by this box. This system runs on a 5-volt power supply and ground, which I call 0 volts. Now what I want to do is I want to design a power indicator light that tells me that my power is on. And to do this, I want to use a light emitting diode, an LED. I have an LED that is rated at 16 milliamps at 1.8 volts across the LED. And the LED has a maximum current rating of 25 milliamps. So I don't want any more than 25 milliamps to run in this diode circuit. And I'd prefer to run close to the typical current of 16 milliamps with a 1.8 volt drop across the light emitting diode. Now what if I were to hook up the LED across the power supply like this? Now that would not work because it would be reverse biased and there'd be no current flowing. So let's undo that. What if I hook up the LED this way across the power supply? Well, that would be not a good idea, because I'm going to exceed my 25 milliamp current rating and I'm going to destroy my light emitting diode. So let's undo that. So I want to limit the current in some way. So I could put my LED this way, and I could put a resistor here to limit the current, or I have another choice. I could put my resistor up here and put my LED down here. Either way should work, and this has perhaps a very slight disadvantage in that I have a little higher voltage at the LED. Here I have 5 volts, and here I have a little less than 5 volts. In this case, my LED has a cathode at ground, so it's a little lower voltage. And since the LED is going to be on the front panel, I think I'd prefer to put a little lower voltage at the front panel. So I think I'm going to erase this. And choose the configuration with the diode connected to the ground. So let's calculate the value of this resistor R so that I have 16 milliamps in this resistor while I have 1.8 volt drop across my LED. So recall that resistance is equal to voltage divided by current. In this circuit, my voltage is equal to the 5 volts minus the 1.8 volts across the light emitting diode divided by my current, which I want to be 16 milliamps. Now when I use volts and milliamp, the result comes out in K. This comes out 0.2 K ohms, or 200 ohms. So if I use 200 ohms in this circuit and my power is on, I have 5 volts across this network, I'll have approximately 16 milliamps flowing in the resistor and through my LED. Now if the power is off and this 5 volts goes to 0 volts, then I'll have no current flowing in the LED, and the LED will be off. So it seems like this should work fine as a power indicator. So let's evaluate this resistor. Now, in a way, I've lucked out. For 5% resistor tolerances, a standard value at 5% is 200 ohms. But perhaps I want to go with a 10% resistor, a little looser tolerance, and save perhaps a little money. But my standard values for a 10% resistor is 180 ohms and 220 ohms. So I don't get the 200 ohm resistor, but maybe it'll still work. So let's consider using 180 ohms. So let's consider, am I going to exceed my 25 milliamps at any time in this LED? So let's say that I have this 180 ohm resistor, my light emitting diode, connected to ground. And let's say that the power supply can be 10% high. So instead of being 5 volts, it's at 5.5 volts. That'll give me the most current in this resistor. Now, if my resistor is at a low value, instead of 180 ohms, if it's 10% down, say at 162 ohms, and if I have the minimum possible drop across my LED, which I'm going to say is a little less than the 1.8 volts. I'm going to be a little safe, say that could be 1.5 volts. So under these conditions, that's the worst case for this maximum current. So let's see what the maximum current could be. So I maximum is equal to the voltage across the resistor, 5.5 minus 1.5 divided by 0.162 k ohms, and that is equal to 24.5 milliamps. So I am under the maximum current, but I'm a little close. And so this makes me a little nervous. I'm very close to that 25 milliamps. But maybe the 220 ohm would be a better choice. So let's see what my min current might be. This will be less current in the LED, but it still might be okay. But let's see what the min current would be. So if I use 220 ohms instead, I calculate my I min, and this would be when my power supply is at the lowest, which I'll say 4.5 volts, say it's a 10% power supply, and minus, now the maximum voltage across my LED is spec'd at 1.8, but I'm going to be a little safe. I'm going to make it a little higher at 2 volts. And if the 220 is a little bit on the high side, at 10% high, 242 k ohms, this will give me 10.3 milliamps, which is a little bit far from my ideal 16 milliamps. So I think that I'm going to prefer to use the 200 ohm 5% resistor, and let's calculate what the resistor wattage needs to be. So let's figure the maximum power that this resistor could dissipate. Again, that would be when my power supply is at the high side, connected to a resistor that is at the low side. So we'll say it could be down at 190 ohms. And let's say that my LED, let's say that that is at a minimum 1.5 volts to be safe. Let's calculate the I max will equal to, this would be 4 volts across my resistor divided by 0.19K, which is equal to 21 milliamps. So I'm under the 25 milliamps, so that should be fairly safe. But let's calculate what my maximum power would be. Now recall that power is current times voltage. And in this case, the current is 21 milliamps, and my voltage is 4 volts. And that is equal to 84 milliwatts. So if I use a quarter watt resistor, which should be 250 milliwatts, that should be quite safe. So I'm going to choose to use a quarter watt resistor, 5%, and 200 ohms. Let's design a very simple circuit using a diode. Let's presume that I have an electrical system as shown by this box. And to do this, I want to use a light emitting diode, an LED. I have an LED that is rated at 16 milliamps at 1.8 volts across the LED. And the LED has a maximum current rating of 25 milliamps. So I don't want any more than 25 milliamps to run. This system runs on a 5-volt power supply and ground, which I call 0 volts. Now what I want to do is I want to design a power indicator light that tells me that my power is on in this diode circuit. And I'd prefer to run close to the typical current of 16 milliamps with a 1.8 volt drop across the light emitting diode. Now what if I were to hook up the LED